Graphing a parabola in vertex form, section 3.1. Recall the quadratic function f of x equals ax squared plus bx plus c, where a is not 0. Remember that the shape of the graph for a quadratic function is a parabola. The vertex form of a quadratic function, also called the standard form of a quadratic function, is f of x equals a times x minus h squared plus k. The h tells you to go left or right, k tells you to go up or down, and a indicates a vertical stretch or shrink. And also, if a is positive, it would remain in its normal position. If a is negative, then the graph will be flipped upside down. The vertex is what we want to really focus on here because it's the highest or lowest point on the parabola, and we denote the vertex by h comma k. To find h, you're going to set the part inside of the parentheses equal to 0 and solve for x, or just take the opposite sign. To find k, follow the sign on the outside. All right, so in vertex form, if a is positive, so if a is greater than 0, the parabola is going to open up. The vertex h comma k is going to be at the bottom, as you can see, and so therefore the vertex is going to be a minimum. The vertex will be a minimum, and that minimum value is always equal to the second coordinate of the vertex, which is k. We also have an axis of symmetry, which is the imaginary line that the graph is symmetric about, and that axis of symmetry is x equals h. So here's an example so that you can see the axis of symmetry. Here it is the imaginary vertical line that the graph is symmetric about. So, if a is less than 0, All right, so if a is less than 0, the parabola opens down, and the vertex is h comma k, and it is going to be the highest point on your graph. So you can see here that the vertex is at the top of the graph, and therefore it's a maximum, and that maximum value is equal to k. It also has an axis of symmetry at x equals h. Remember that h is the first coordinate of the vertex. Whenever you're writing the axis of symmetry, you need to say x equals because it represents an imaginary vertical line. All right, so let's consider an example. Let's say we have f of x is equal to 2 times x plus 3 squared minus 4. Let's maybe, I would like to edit this, but just because I want to make it something a little nicer to work with, I wanted to edit it, but I'm going to leave it as is. So, does the parabola open up or down is the question. Does the parabola open up or down? The answer is up. How do we know? Well, since a So that means that this graph is going to open up. All right, so the graph is going to open up. All right, what's the vertex? So what's the vertex of the parabola? To find the vertex, remember we said take the opposite sign on the inside, follow the sign on the outside. So that means your vertex here is going to be a -3, -4. All right, and then the axis of symmetry. The axis of symmetry is the imaginary vertical line that the graph is symmetric about, and we said that is always x equal to the first coordinate of the vertex, which is, in this case, -3. Is there a minimum or maximum value? Is there a minimum or maximum value? Well, because the graph opens up, that means the vertex is at the bottom, and therefore you have a minimum value. And that minimum value is always equal to the second coordinate of the vertex. In this case, that will be -4. All right, so let's find the x-intercept. So to find the x-intercept, what are we going to do? Well, we're going to, in our problem, which is f of x is equal to 2 times x plus 3 squared minus 4. The first thing we're going to do to find the x-intercept is set f of x equal to 0. So we have 0 is equal to 2 times x plus 3 squared minus 4. So we are going to add 4 to both sides. And then we divide by 2. We get 2 is equal to x plus 3 squared. Then we take the square root of both sides. We get plus or minus the square root of 2 is equal to x plus 3. So then -3 plus or minus the square root of 2 is equal to x. You can put these values into your calculator just to kind of get an approximation of what they are. So if we type this into our graphing calculators or our calculators in general, x will be equal to -3 minus square root of 2, or x will be equal to -3 plus square root of 2. So if we put this in our calculator, then -3 minus square root of 2 is equal to a -4.4, and -3 plus square root of 2 is approximately a -1.6. All right, so that is our x-intercept. Let's look at the y-intercept. How do you find y-intercepts? Well, to find y-intercepts, you replace x with 0. So everywhere in your function, this original function up here, everywhere in the function that you see x, you're going to put 0. So then we have 2 times 0 plus 3 squared minus 4. So then we end up with 2 times 3 squared minus 4, which is 2 times 9 is 18 minus 4, we get 14. So if we go back and list all of our ordered pairs, then they are going to be, my x-intercepts as ordered pairs are going to be -4.4, 0, and negative 1.6 comma 0. And then for my y-intercept, it'll be 0 comma 14. All right, so 14 is off my grid, so I'm not going to try and actually sketch that. Let's go ahead and plot our vertex, which is, our vertex for this problem is negative 3, so left 3 and down 4. Here's my vertex. My x-intercept is at negative 4.4, so maybe a little short of halfway, and negative 1.6, a little beyond halfway, like so. The y-intercept is at 14, which is way up here, right? So this is 10, 11, 12, 13, 14, so maybe up here somewhere. So my graph is going to do something like this. All right, there's my parabola. If I want to sketch my asymptote, not my asymptote, but my axis of symmetry, then my axis of symmetry for this problem is going to be x equals negative 3. So I would sketch my imaginary vertical line at x equals negative 3. And that is my axis of symmetry. All right, so there's a graph. Hopefully you understand, and we'll see how it goes from there.